Hello and welcome to another community stand-up with Kevin Gallo. My name is Seth Juarez, and I'm privileged to have, as always, the Corporate Vice President of Windows Developer Platform here with us to talk all about Windows. The important thing is remember that these questions, we want you to ask questions. This show is all for you. It's not about what I have to ask. I will steal their whole hour if you let me, so please make sure to ask your questions or I'll steal the whole hour. So, Kevin, why don't you catch us up from last time? What are some new things that we should be excited about with Windows?
Well, the big thing that happened really was CES, right? So we did, several announcements there, and we had a lot of announcements about our continued support in the Always Connected PC. We announced some there's some announcements of some new products, mainly one from Lenovo, the Mix 360. We also announced prior to that at the Qualcomm Summit some also Always Connected PCs from HP and Asus. And really, this is a new category. There's a PC that combines the simplicity and the mobility of a phone with the creativity and power of a PC. And it also works on multiple different architectures like ARM, and so we've introduced some new technologies with Qualcomm to support PCs in this category.
So I understand you brought a guest so that I can pepper her with tons of questions. Why don't you introduce her for us?
So basically, we brought on Erin Chapple, who's going to tell us all about this Always Connected PC and kind of what it means for the industry.
Yeah. Thanks.
So let me just ask a couple of questions. I'm completely curious as a dev. This is for developers, obviously. So Sue Dev might be watching. She might be thinking, Always Connected PC, how is that different than a regular PC, and how should I think about it as a developer producing applications for it?
Yeah, and so I first of all, thank you for having me here. It's really exciting to be here to be able to talk to the developer community about this new device. I think it's really important to ground why we do these products and really what the Always Connected PC category means to us at Microsoft. Kevin, you teed it up really nicely. If you're like me, over the last several years, you probably have found yourself leaving your PC in your bag more often than not, and really becoming dependent on this mobile experience that you have. I am the queen of editing files, PowerPoint files, whatever, on my mobile device, which really doesn't help my creativity and my productivity. And so hence comes this Always Connected PC category, where we really want that simplicity and the connectivity of the mobile device and the experience you have, but giving you and unlocking this creativity. So for us, there really are four key points to the Always Connected PC. First, it's always connected. Built-in LTE, the ability to seamlessly switch between Wi-Fi and LTE, the OS really providing a lot of capability that does that natural switching for you so the customer doesn't even have to think about it. The second is great battery life. Right? And we often talk about the Always Connected piece, but for me personally, the battery life has been the thing that's really changed my behavior as a consumer of this device. We're talking about days, not hours, of continuous battery life, and weeks, not days, of connected standby. And if you think about the combination of those two, I took one of these devices on holiday with me for a week, and sure, I wasn't using it every day, for the 8-hour workday, but I used it 2-3 hours a day. I watched a movie, I did some photo books, etc. And I only had to charge this thing once in a week. And when you really get unfreed from the shackles of Wi-Fi and searching for public Wi-Fi, and then the power cord, that becomes really liberating as a user. And then the last two pieces are, it's just Windows. Right, it's the Windows we know and love. It has all of the Windows, Hello, inking, touch, all of those things. And so users can expect it to operate just like they would, their Windows that they know and love today. And then lastly, it really affords these new thin and light designs that fit with that mobile experience and fit with that being able to stick it in your bag and go anywhere with it. And really think about how I have found that last night I was waiting for a friend. They were 15 minutes late to meet me for dinner. I'm sitting there in the restaurant. I popped out my Always Connected PC, and I was productive for the 15 minutes while I was waiting, and I was like, no problem. Actually, if you want to be another 15 minutes, great, I have stuff to do. So it really changes that whole experience you have.
So let's talk a little bit, because obviously these Always Connected PCs, and forgive me, I have tons of questions.
Yeah.
It's a different architecture, it feels like, and it's using different kinds of chips. Can we start with what kind of chips are actually being used in them?
So the Always Connected PC is a category, and we really embrace silicon diversity. And so you'll see devices from multiple silicon vendors from multiple OEMs. But one of the things that is really interesting in this first wave of devices that we have is we have used our partnership with Qualcomm to really take advantage of some of the architecture and the features of the underlying 835 Snapdragon chipset in order to be able to light up these features, right? So first and foremost, it starts with the chip. Qualcomm has just had long experience in battery life and really being able to be experienced with that always connected scenario, that instant on. And so just the architecture helps us with these long, battery life. The second thing is the Qualcomm chipset is just small, right? It's got an integrated built-in, LTE chip on the SoC, and so that enables us to get efficiencies, out of the performance and the power, of the system, and that in turn enables these thin and light designs, right? You can put a bigger battery in it. You can actually have fanless devices, and so that we think will unlock a set of new types of devices that we'll have. So that's kind of the first. Now, you might be thinking, okay, well, great, we got this chipset, but like what did you have to do on the OS side in order to make that work?
Yeah.
And so, and I think probably people might throw back and, hearken the days of RT and say, well, wait, why is this different? Why is it going to be any different? I think first and foremost, the chipset is different. We're in a different time. And second, we're taking a different approach to how we think about this, right? This is a new category, and we really natively recompiled the operating system to run on this device. And so we really are bringing the full power of Windows to the device. And then we've really thought about, well, what does the user do with this? They want to bring their apps, right? We're talking to the developer audience. That's a really important piece of it. And so we've invested in our Windows on Windows abstraction layer to be able to emulate x86 apps running on the ARM architecture in order to unlock the ecosystem of applications that we have today.
So this is crazy talk for me as a programmer. I remember doing, because as I'm thinking about this, the ARM chips, for example, the ones from Qualcomm or whatever we're running on, they have different instruction sets.
Yeah.
Right? Like when you get down to the fundamental, the instruction sets are different. So when you say Windows on Windows, I don't understand how this is, how is this happening? Give me a rundown.
Yeah. So we're actually using dynamic binary translation to, on load of the application, convert, right, chunks of code into ARM code and be able to run it on top of this device.
Is this something that, am I going to notice that is it performant, I guess is my question?
Yeah, and we can get into kind of the details of it. I think maybe before we go there, let's first maybe start by showing it. I'd like to invite a special guest up here, and then we can maybe come back to the performance, because people, I think, should see, first and foremost, I think when people get their hands on it, does it even work? And I can assure you, right, many of us within Microsoft have been self-hosting these devices. And so I'd like to invite Hari from our team. Hari is the principal group program manager for the Windows kernel team. Mm-hmm. His team has been really behind the magic of a lot of this. And
Have a seat, Hari.
If he could come and just show us maybe what the experience looks like from a developer point of view.
It's a great idea. Love this. Let's do it.
Cool. Sorry. Thank you. Thanks, Kevin. So I'm going to show you two demos. So for the very first demo, I'm going to show you, since the developer-focused audience, I'm going to show you a remote debugging scenario for WPIP.
Okay.
And then finally, I'll show you the x86 emulation app in action, so that there are no more questions about performance, and we can deep dive there.
Let's do it.
All right, so I'm going to look at the Surface laptop on the right. This has my Visual Studio. This is my dev environment. This is what where you want to open your Visual Studio and start coding. What I have here is an MSDN sample app. So this is available on MSDN. Just download it. It's a simple UWP game app. And so I actually set up a breakpoint at the very start in the constructor so that when I remote debug this and deploy this onto the Snapdragon PC, you can actually see it break in. You can look at the stacks, and you'll see that this is real. There's no hand magic here.
Okay.
All right, so let's do a remote demo. So let's do a remote deploy. So the first thing you want to do when you do a remote deploy, you want to go in your project properties, go to the debugging tab, make sure you've given the IP address of your remote PC. And since I already have this set up, I already did this, make sure your authentication type is universal, right? As you can see, it's right there. I did all of that. And since we are now deploying to an ARM PC, you need to make sure your architecture in the drop-down here is ARM. As you can see, I did that too. And on the remote side, if we can switch the display back to the Always Connected PC. And we're waiting for the display.
All right, let's switch. There we go.
There you go. All right. So there, I am now on the Always Connected PC. You can see the IP address here. It's the same that I just showed you. And you know that this is a Snapdragon PC because I'm going to pull up Task Manager. I'm going to show you that this is a Snapdragon processor, 835, 8 cores, 4 big, 4 little. So this is the final deal. And so that's it. And so when you need to do this, one of the first things you need to do, you need to make sure you enter into developer mode so that you can deploy your apps and debug them. And so I already did that. I set up the developer mode. The next thing you want to do is you want to make sure you enable device discovery. And then finally, you need to pair your device with the Visual Studio environment so that it can talk to each other in a secure manner. And so I did that already. This is a one-time action only. You don't need to do this all the time. So I just did this. I already set this up so we don't waste time doing this during the demo.
Nice.
So on my Surface laptop, I'm now going to press F5. And you don't need, I'm going to press F5. Now this will kick off the remote deploy. And now this is creating a package, capturing all the files, and then copying it over the Wi-Fi network onto the remote PC. This is going to take a little bit of time. And while it's doing that, I just wanted to quickly point out, in the drop-down, you saw that I used ARM. And we've been talking about x86 emulation. We could have also used x86 in there, right? And that would have also worked just fine. But since this is a UWP app, we want the ARM package to be deployed onto this one so that it runs natively without emulation, right? So that way you get the best performance out of your machine, out of your apps.
That's awesome. So this is very similar to what we would do with a Xamarin application, for example.
That's right.
And it's just deploying it directly to the machine.
So this is exactly a piece. This is just a PC. Everything I showed you is documented on MSDN. So so if you go and do the walkthroughs on MSDN, it's all the same. Doesn't matter whether it's a Always Connected PC or it's a Surface laptop or it's your Lenovo or a Dell PC. There's no difference. It's all just a PC.
And when I'm writing the application, is it just regular UWP writing things?
It is just a regular UWP app. If you see this, there is no code changes. It is exactly the same code. I downloaded from the MSDN, made 0 code changes, ran it on ARM. Presumably, the person who wrote this app never even has seen an Always Connected PC, right? Like we haven't released it yet.
In store apps, basically, we've always recommended that UWP developers submit an x86 as well as a ARM, and most do. Some don't, but we always encourage them to. That way, any store deployed app, there's already a ARM version of it in the store for UWP, and those are the ones that will run on this device.
Awesome. Awesome. This is pretty amazing. So when you deploy it, it's actually taking the AppX.
That's right.
And then it's moving it over.
That's
and
right.
then does it run it as well? And so you're debugging it?
It launches it, and now as you can see on the screen,
All right.
I've actually broken into the app. I put a breakpoint in the constructor, so you can see this is live. There's no magic here. Stack, you can see the stack right here. You can see the code. You can see the variables, the local variables. So I'm going to hit F5 so that we can go ahead and launch the app on the remote machine.
Let's switch to the
And
remote
so
machine.
if you can switch to the remote machine, there you have it. The game's actually launched. It's the game, and I'm going to actually show you it's real live here. There's no tap to continue. It's a pretty silly game. But as you can see, the performance, instantaneous. There's no lag. There's nothing, right?
Holy cow.
Let's shoot a couple of balls. And as you can see, there's no lag, nothing.
And now the reason why this is doubly impressive for me, which is thank you for, let's just see what it does. Because this is actually in debug mode.
This is in debug mode.
And the thing about debug mode, we all know that there's all these symbols that get generated and there's all these other things that are happening, but even in debug mode, it still feels really fluid.
Yeah, and this is an ARM version, so it's running natively on the system, so remember, so that's why there's no emulation in this path yet.
And that's pretty amazing. I mean, how did you squeeze all the power out of a chip like that? And you're like, we're not telling anybody. Okay. It's pretty amazing. The other question I have, and you alluded to this a little bit, and then we'll get to your questions, is you mentioned there's Windows on Windows x86 emulation, which effectively takes one instruction set and maps it to another. Can you tell us a little bit about how that works?
Should we first show you a demo of that?
Yes.
And then we
Look at that.
That way
Real
you
code.
can see what
Real
we're
code.
talking about.
Love
Real
it.
code. All right, so let's close this remote deploy, and let's switch back to the Snapdragon processor if we can. Okay, and so since the developer focus talk, what I'm going to do is I'm going to show you. I'm going to install GVim, right? So no jokes about Emacs, please. I don't.
Oh, nice.
So
how are we going to exit out of there before the end of the show? I don't understand.
So, all right, so this is a GVim that I just downloaded straight from the web. There's no magic here. I just went to vim.org. I already saved it on the desktop previously to avoid, to stop wasting time. And there you have it. Yes, please install. And so I agree. Let's create a batch file so that we can easily launch it. This is just what you would see if you're installing GVim on your PC. There's running normally, it's running just as it would on any PC. You don't see any lag, you don't see any...
I don't think people are understanding what's happening.
Right.
I mean, I feel like this is not an executable that any of us ever built.
No.
Anywhere in our entire Windows anything. This
No.
is GVim, somewhere else, you know.
Yep.
And it's built for x86 type processors.
right.
And you're just installing it like nobody cares, right?
Nobody cares.
It's like walking into another country expecting to speak English without a problem.
That's right.
Right? And how do you do that?
That's right.
And so
So let's just show you
Yeah,
again. Yeah,
please.
so that installed, as you saw, it would install just like any normal PC. It's just a PC, right? We get to install x86 Win32 apps just like you would. There's no special secret key, press this, press that. So now I'm going to launch GVim, and there you have it. It's just launching like you would. Hello world.
And obviously, we're just going to have to leave it open for the rest of the time, because no one knows how to get out of there, right? But this is pretty impressive.
No, I'm not going to fall for your bait.
Oh, okay. WQ exclamation mark. Don't say. This is amazing. So now that you've showed us this actually working, I got to know, how is this Windows on Windows thing working? It's the first time I've heard of this.
Yeah, so as I talked about, when that application loads, what we do is we use dynamic binary translation in order to convert, right, the x86 code into ARM code and run it on the system. And so we do that translation, right? And in some sense, it's as complicated and as simple as that. Now, I think the question, which kind of goes behind that, is, well, what is the performance of this look like? Because, you know, if you're doing this, right, in real time in some sense, what does that look like? And, you know, there's a couple of things to point out here. One is that, again, I want to start with, we've natively recompiled the operating system so that things that are talking, right, to the hardware, to the kernel, are running at native performance speeds. So then it really comes down to, well, how do I get the most performance out of that application? And we were really smart about thinking about, where did we set that emulation layer, right? Where are we going to do that translation? You know, we have the system DLLs that are native. Should we do the translation above those, right? So that we're getting the native performance of the system DLLs. Well, if you do that, you have some challenges, right? Because x86 applications are using 32-bit data types, they're using x86 calling conventions. And so if you were going to do the translation at that layer, you're going to have kind of more of a performance hit. You know, you have to do the data marshalling, all of that. Some of that can be automated, but it's, you know, it's somewhat complicated. You know, so what we decided to do was actually, you know, have these x86 applications call, you know, x86 system DLLs and do the emulation at the layer below that. And we felt like that was the best trade-off, right, from an app compat point of view and a performance. Now, we didn't want to stop just at that, right? Because we do want to squeak our geeks. We want to squeak out every part of performance in the system. And so I love to have, you know, Hari talk about some of the work his team did on this compiled hybrid portable executable, which, you know, is a little bit of computer science magic in my opinion.
Well, I'm all about computer science magic. Let's hear it.
So actually, if we can elaborate a little bit while I lead into the chippy part. So if you take an x64 machine, just like a Surface laptop, right, when you install an x86 app on it, what really happens is you install it into C program files x86, you have a directory called syswow64, which has all the system DLLs on it. And then, so what, this is the Windows on Windows abstraction layer that Erin was saying. So what really happens is we have the entire user mode thing running as x86. The kernel is always x64. Now the key difference here is that on an x64 machine, the processor itself can natively run x86 code, right? The processor already knows, oh, x86 instruction, I know what it is, I know what to do.
I got all sorts of space left over.
So exactly. So on an ARM machine, the processor obviously does not understand the instructions. And so we use the same syswow64 layer to basically now run our own emulated code. So we'll basically use the same syswow64 infrastructure. It'll trap into the WoW layer, and the WoW layer will take the block of code that it just saw, translate it into an ARM instruction. So move is equivalent of ARM instruction, and then we'll just run it on the core, and we'll run it on the thing. So that is emulation at its core. If you switch to the Snapdragon PC, on the view, there it is. You can actually see what I'm talking about just by doing this. See, there's a syswow64, and if you do that on any x64 machine, you will see exactly that, right? and you'll see a syswall64 on your x86 machine. You'll see C program files, right? x86, see? And there are some more interesting aspects there, which we may or may not want to go into there, but we can. So that's what we are doing. And so Chippy is an interesting technology that we did. Now, if you think about it, the reason we have to do translation is because we don't have source for GVim. We don't have source for any of these x86 apps. So that's why we have to translate them at runtime. Now, however, the code inside syswall64 is all ours. It's all kernel 32 owned by Microsoft. Shell 32, kernel based, that's all our code. We have the source code. So we don't necessarily have to translate them into x86. So that's where the Chippy magic comes in. So what we did is for the code that we own, where we have the source, we've done this Chippy thing, which basically is like, you can think of it as all the code pages are ARM64, but all the interfaces are x86. So that way, when an x86 process is calling into kernel 32, it's actually loading our kernel, the Chippy kernel 32, which is really just ARM64 code, but the interface, the abstraction, the entry points into it are all x86, so it can load into an x86 process.
I see.
So we give the application a little bit of this performance turbo boost, right? Because we can run the code it's calling at native performance levels.
And usually this happens. I'm sorry. And usually this happens when you're going from user to kernel mode. You're doing kernel calls.
No.
All of
the syswall layers are always in user mode.
I see.
Entire WoW layer is in user mode. The kernel mode is always native. Your drivers are always native.
That's why it's so fast.
So when you're doing I/O, native driver. When you're doing graphics, native. When you're doing networking, it's all natives. It's only when you are hitting the CPU, running code, that's when you have to put in the translation layer.
That makes sense. You were saying, I'm sorry.
Yeah, and so I think this just gives a little bit of that turbo boost, right? And now these days we have great telemetry on what our applications are that customers are using. And so as we've thought about like what binaries are we going to enable from a Chippy point of view, are using telemetry of the top applications in order to kind of go through and pick the files that we think will have the biggest impact from a customer point of view.
And that's cool because moving forward, when everyone starts writing all these cool applications, you'll be able to see where you could even squeeze more performance out of it.
Yeah.
All right, so I've been really selfish. Let's get to some questions. Matt Marshall, we've seen several OEMs announce their Always Connected PCs. How is commitment by other major OEMs firming up? Are there many fence sitters at this point?
I think, with any new category that you're launching, you really you want to start, and prove out in some sense the category exists. And so the OEM partners we've worked with, really understand and are leaders in, I would say, the consumer space, which is the first place that we are looking. But one of the other things that, is interesting about this category is the potential over time is not only the consumer space, but also enterprises. Today, a lot of enterprises are really looking for how do they reduce cost and how do they reduce overhead. They're offloading a lot of their storage and networking to the cloud, storage and compute to the cloud. The next logical evolution of that is to offload their network to the cloud and be able to take advantage of this large investments that our mobile operators and carriers around the world are really putting into things like 5G, et cetera. And so, as this category expands and we see really being able to take advantage of some of these other, customer profiles and scenarios, I think the other OEMs will continue, right? We're always in conversations with our partners, and I'm not ready to share anything at this point, but you can look forward to, in upcoming months and whatnot, announcements in that area.
And here's the thing, remember terminal services from a long time ago? This is like the logical, this is how it always should have been, instead of that little cheap little box, and then you had the little thing, and this feels like a natural evolution to something where an always connected PC, imagine with good networking, you'll be able to connect into your things and do stuff from anywhere, really.
Yeah, exactly. For me, it was, you talked about CES last week. One of the things that was my first time at CES that I really experienced was the massive traffic and long taxi lines and whatnot. And for me, I was 30 minutes right from the hotel, 45 minutes from the hotel to the convention center. I'm sitting in the back of the taxi and I'm working on my Always Connected PC. And communicating, and I have, a great network speed as well as all the power of the PC. It really does kind of change the thinking of where you could work, when you can work, how you can be productive.
Awesome. Did you want to say something, Kevin, before I go to the next question?
No, I think it's awesome.
All right, Matt Marshall again. We've seen a number of carriers commit to supporting Always Connected PCs. Is there a good reason to expect universal support by cellular carriers internationally?
We are, of course, in talks with mobile operators kind of globally. And I think, as we talk about having, built-in LTE connection, the Asus Novago is the first gigabit-enabled laptop, right? And so these mobile operators are also really interested in getting additional endpoints onto their network and consuming their services. And so really that's driven by the OEM and the mobile operator connection as they go to market in the retail channels. But you'll see us kind of launching, in different markets around the world over the upcoming, year. And
this is cool because we all try to do work on our phones and then we get annoyed a little bit. Can I say annoyed? It's like, I feel like if it was just a little bit bigger, I could do this. This feels like the perfect step up to where you want to be productive, but you're not necessarily running a high-end graphics card, for example.
And then the other thing that's really interesting is that today most of these devices and most of the cellular experience is based on physical SIM. Right? And so you go in and you put a physical SIM into your device. But these devices are also capable of running eSIM. Right? And so, as the eSIM technology progresses and carriers get the infrastructure around the world, it started today with some other devices, right, that are eSIM enabled, then you could expect, right, the experience to be that as I move geographically, might be able to, right, reconfigure in order to be able to move between and purchase, right, data on the go or whatnot. So it's the world we envision seeing over time. And it's not there today, right? But you can see directionally where we're going.
I just think even in the enterprise, think about your employees being always connected. Again, you have to have a phone, sometimes you have to tether to it. You can't get access to all your applications. Here you get kind of the benefits of both. You're always connected, you can use that device in the field wherever you're going, and you have access to all of the applications and experiences that are already existing on Windows. And as Hari went, they just run. They just run. The end user, the user using the device doesn't have to think, do these apps work, these don't. All the apps that you know and love, whatever you need in your enterprise, they all work.
Awesome. All right, next question. Windows 10 on Snapdragon can run non-store, non-UWP, non-desktop bridged ARM64 binary desktop applications? That was a lot of qualifications. So it's effectively an ARM64 binary desktop application. Can it?
So let me see if I can see if I can. I'll answer the question in general. Maybe it answers this question. Is we can run x86 applications in this WoW 64 layer. We can run native UWPs that are either compiled for x86 or preferably for ARM32. ARM64 support, we have ARM64 compiled binaries. We have not yet released an SDK that does that. That's something that we are going to do in a future version of Visual Studio. We'll be able to natively compile your code into a ARM64 binary. We do not currently support if you did an x64 binary. That currently will not work, so you'd need to use your x86. And most developers have x86 and x64 versions of their application, so the user just need to have a x86 version of that to run.
Sorry, to hit that point again, so if you're submitting a Centennial app to the store, please make sure to submit the x86 version of a Centennial app so that we can...
Yep.
Absolutely. Good question. Jim, there's another one. Are you working on 64-bit emulation? I think you just kind of answered that as well, right?
We're not really looking at 64-bit emulation. Instead, we want to go and just compile it to an ARM64. We think most people who are going to want that 64 are going to want better, more optimized performance for x64. So we're just going to go and support that natively with ARM64 compiler.
Awesome, great question. Is Desktop Bridge, will Desktop Bridge be the only way for third-party devs, non-OEM, to deploy Win32 apps to Windows 10 on ARM?
Actually, I think we just,
the whole
demo was
we literally just
take
showed
them off the web and run it.
Yes.
Yeah.
I think the answer is yes. I can say with 100% confidence. Next, what x86 processor is emulated? Does it support AVX? That's kind of a deep down there.
Yeah, that's the way. I think I would rather not say exactly what specs we support, but yes, AVX is supported. We do emulate. Windows has a minimum requirement of what instruction set it supports, and we support the minimum instruction set for x86 apps for emulation.
That's cool. I mean, just the fact that there's probably someone, she's sitting there like, here's the list of all the instructions. We got the check, and it's pretty cool that we do that. Next one from Michael. What are the design considerations that we should take into account for our UWP apps for Always Connected PCs? Because here's the dev question, and let me see if I can retranslate, because it's something that I had as well. It's like, this is a new form factor, And the great thing about Windows is that, for example, we have Windows 10 IoT, we have Windows 10 on the desktop, now we have Windows 10 Always Connected. It feels like when there's a new form factor, you need to make certain kinds of design decisions as a developer. Can you help us out with what those might be?
In many ways, when we designed UWP, we made sure that it would span devices that were always connected, like phones. It would also work for devices that were powered, and even things that are always plugged in, like your Xbox. So in many cases, the UWP platform was designed. We do things in asynchronous. You don't want to go and just sit in your loop and just burn a bunch of battery. You need to be able to save state quick. So you always have a save state model. So there's several patterns that were built directly into the Universal Windows platform around an always connected application. And mainly coming from our phone heritage and our, basically an on-your-go, even HoloLens. Very battery sensitive, very smart about not tying up the processor. So a lot of that technology is automatically built into UWP and is part of our guidance for building a modern application.
So if you are
just to interject,
Yeah.
I think the other point to say is this is just a PC. What you're designing for is the form factor.
Yeah.
There could be, don't try to think too hard about what processor is running on. It's just the form factor. You're designing for a device that looks like this. You're designing for a device that has long battery life. It has good connectivity. That is what you're designing for. You're not designing for the processor.
Yeah. I think it's the customer scenario at
Right,
the end of the day, right? It really is about thinking about what new behaviors or patterns would having a device like this unlock from a customer point of view that you, from an application developer point of view, could take advantage of in terms of delivering value to that end customer.
That's awesome. Yeah, and like I said, I think this is a great idea. Lance asked, with Windows 10 Pro, are there any feature differences between ARM and x86 versions? So you're not installing Windows 10 Pro on these kinds. Is it a different flavor of Windows?
No.
Oh, well, that's easy.
No.
That's an easy answer. It's the same thing.
No.
That's awesome. Well, Jim, that was an easy answer. So next, when can I buy a device for development? Are they all shipping with Windows 10 S?
Each of the OEMs has their retail plan, right? You can expect to see, I think, actually the Asus Nova Go, if you're in Taiwan, is actually available as of now. But over the upcoming months, you will see availability, right? Here in the U.S. as you think about retail. The Asus, HP, and Lenovo devices will start in 10S mode. And the reason behind that is really when you think about 10S, the benefit to the customer of 10S is performance, battery life, and security. And if you take that and align it with the value proposition of the Always Connected PC, right? We want the experience you have on day one to be the same as day 1000. And so the performance aspect, that long battery life, and then you're always connected, the security and really being able to trust that is actually something that's really important.
But that doesn't preclude me installing different flavor of Windows.
They will all, at least those 3 devices will launch with 10S, and then it's a user choice if they want to switch to Pro, right? And that is a free switch that they can access through the store. And then it really puts the power in the hands of the consumer as to what are the trade-offs that they want to make.
That's awesome. I mean, I could see, for example, in an educational environment where there's people just have 10S because I don't want my kid breaking out of a certain sandbox, for example. I can see certain examples of kiosk settings where 10S is just perfect, right? I mean, it's just, I guess it's up to you what you want to do. Awesome. Mary UK, I know her. How are you? How about installing apps that have an MSI? Installers are often x64 rather than x86.
We have full MSI support. I just showed you the GVim installer, which was an MSI, so I installed it. So as Kevin already mentioned, we don't have x64 emulation. We have x86 emulation. In our telemetry, in our experience, almost all of the developers have an x86 version of their app because that is the least common denominator if you use the math speak, right? Like x86 runs everywhere, right? And so we feel confident that if you have x86 emulation, we have the widest breadth coverage. And then, as Kevin said, we'll have the SDK for Arm64, and so for people who really want the 64-bit virtual address, the more memory, the increased performance, they recompile to Arm64.
So actually, you can,
go ahead.
Just interesting enough, just kind of if people want to play with it, the current SDK that's out there in version Visual Studio, if you go in and try to compile for Arm64, you can actually compile for ARM64. So it is available out there for people to try. You can't publish an app to the store yet. It's not really ready for prime time. But if you want to kick the tires while compiling your application to ARM64, it's not, not making it, they don't have project templates for it yet, but you can play with it for C++ code. So if you have a C++ application that's x64, go give it a try, recompile it, and give us feedback.
Tell us if it works.
I think the other thing I would kind of state here too is that as a developer, you really want to think about what your target audience is and your customer. And so, I would maybe go back and think about, and maybe to weave in some of the performance things as well. Think about Office, right? Office was an interesting conversation for us to have internally. Right? Because while in some sense, the geeks in us would want it to be, the most performant version of an application that we would ever release, there also is this other interesting angle with Office in that it has a massive ecosystem of add-ins, right? And so if you were going to natively recompile Office for ARM64, you would break compatibility with that ecosystem.
Right.
Well, it turns out, on the other hand, that Office is actually a prime candidate for emulation, right? Because, as back to what Hari said, the nature of the type of work that it's doing, it's actually not doing a lot of CPU intensive work. And so we were able to, with that in our chippy work, really get great performance out of the Office application. So as a developer, I think you got to understand, okay, the target consumer for this device or end user for this device, whether a consumer in an enterprise, is someone who's on the go. It's someone who is, think about a real estate agent, right? Their office is kind of their car, whatever home they're selling, et cetera. They want to have all access to all their information. They want to be able to be on the go. And so, is the performance, if I put this device versus the best device on the market, right, and I launch the apps side by side, is that the thing that's going to drive them? Or is it really the fact that I don't have to think about security of public Wi-Fi, I don't have to think about hunting for Wi-Fi, I don't have to think about being plugged into my battery, I can just do my work whenever I want to, wherever I want to. And so as we're making these decisions about, do you think about emulate, do you go kind of ARM UWP, do you take your x86 app and those are things to think about, is who's going to use this device and how do you get the value to that end user in a way that is the right trade-off for you, because as a developer it's your cost as well as you think about that, right?
I love the way you're literally saying it's Windows.
Yeah.
Now think about your users and how would an on-the-go person use your app. But don't worry about the Windows stuff. Windows is just Windows, right? I love it. Okay, another one from Jim. What frameworks are included in the Windows OS that are x86 versus native ARM? For example, is .NET Framework included? Is it ARM64, x86? It's going more to what's there? Well, Windows, right?
It's Windows, it's just PC. You got the x86.NET Framework on it, it's just a PC.
And a big part of that, I think what Erin touched on, is if we did some of those things native, the connection then to extensions or plugins, or many people build these extensions, it would break compat there. So that's why we did it fairly low, and we even worked with Office to make sure their ecosystem of x86 compiled extensions work. So we didn't want to change too much. So a lot of these things that live up in that layer are all running x86, and really it's only that layer. So .NET Framework and everything are all running x86. That gives us by far the highest compatibility. And that was a big goal.
Yeah.
We just want the apps to run. And the end user and the developer doesn't have to do work, then they can. If they choose, if there's reasons for them to do additional work, then they can do that for benefit to them. But right out of the gate, the device runs all the apps.
That's nice. Another one from Michael. Any special technical details about .NET Runtime for WPF WinForms? Is it somehow specially optimized? Should we avoid using some specific APIs in order to ensure smooth execution of WPF WinForms? Regular non.NET Win32 applications? Is there, you don't have to, I feel like this is the same question but in a different flavor.
I take it as, what are some patterns that probably you don't emulate well, so they can kind of learn, okay, these things are probably slower and these paths are really optimized?
Yeah.
I would say the generic answer is, try to make your code as fast as possible on an x86 machine. Don't worry about the emulation aspect of it. Just make it fast, use the best compiler optimization options, use LTCG, use maximum optimization size, perf, decide what is right for your app and use that. And we'll figure out how to make it run fast. Don't worry about trying to tailor your code for the emulation aspect of it.
So no while true loops for me anymore. I got to take those out. Another one, will pure any CPU.NET Framework apps JIT to ARM64 or x86?
No. We actually, even if it's any CPU, we will If it's a desktop framework, we do run it as x86.
Okay. And then it goes into the emulation layer, and then everything's hunky-dory. Next
and
one.
then also, Kevin's point, longer term, there will be the Arm64 SDK, and at that point, we can talk about JITing to Arm64 at that time. But right now, even if you're any CPU, you will go to x86.
Yeah, it's only really these applications that compiled to x64 because they needed more memory space.
I see.
Right? So when we actually looked at the x86 versus x64, there's a few reasons that people go and do it, and those are probably where people want to natively compile for similar ones. But other than that, staying with x86 is really perfectly fine. For UWP, we still recommend ARM32 because it's easily supported right now, and every time you submit the apps, most people have submitted that, and they'll run a little bit better. But for desktop applications, the x86 one's really what you want to need unless you really have a memory space problem or something special that you needed 64-bit, and usually it's because you went to x64 for that same reason as well.
Exactly.
All right, next question. Is it realistic to expect running Visual Studio eventually on Windows 10 on ARM? I don't know why you would, though. Because just to get to your question of when I'm on the go, if I'm opening up Visual Studio, I'm literally committing myself to a couple of hours. But if I'm opening something like Visual Studio Code, I'm committing myself to just a couple of minutes, right? And so, how do you answer that question?
I think Erin said that really well. Like, the target audience for this is not, if your primary goal here is to sit by this device and do Visual Studio development,
it's probably the wrong device.
It's probably the wrong device for you, right? Like, don't buy this. Go buy something else, right? Like, this is not the device for you.
Yeah, but
if you're asking a technical question whether it will run, yes, it will run. But the point is, what seems like
But something as light as Visual Studio Code, though.
Yes.
I mean, because it's all just x86, though.
Yes, it's all x86.
Awesome. Will these be usable with the Windows Insider program?
Yes.
Yes.
Because it's just Windows.
Just Windows.
Just PC, man.
These are good answers. I'm starting to know them as well. I might be able to answer them in a second. Will UWP.NET apps be supported?
Yeah, they work now. You go to the store and
I could have
download
answered that one myself. I should have answered.
I just
jumped in
showed you a
too fast,
demo
huh?
of the UWP app.
Yeah, he did. So if we got it right, it's pretty much like how Itanium IA64 was all about. I don't know. Maybe do you know what they're talking about?
I think he's saying Itanium was emulating the x86 instruction set, and maybe conceptually, I guess it's right.
It's at least as good.
So the other question I have is, memory must be different in the two different architectures. Or, I mean, I don't know. I don't know enough about ARM. I know how x86, I know how x64, I know about RISC and sys operating sets, instruction sets, but I don't know enough about ARM. Is memory the same? And if it isn't, how do we handle
So there's something called memory ordering, which processors have. So Intel has one way of memory ordering, and ARM has a more looser. They use terms like consistency. ARM has a looser consistency. Intel is more strongly ordered. And so what basically, I'm going to hand wave and give a very high level answer, so please don't send me flame mails if you guys don't like it. But the idea here is that if you have a multi-threaded program and you're writing to a variable, you need to make sure that the changes that you make to the variable are visible to all the threads. And so Intel has one way of ensuring this, and ARM has a different way of ensuring this. And so when you have an x86 program, it's been compiled assuming that it's running on x86, right? So that's the natural assumption. So the compiler generates code with that memory ordering for Intel. On ARM, with a looser memory ordering, if we just let it run as is, apps might crash because the apps are right?
It's like you're looking for your keys. Where did I put my keys? Who moved my keys, right?
Exactly. You're looking for a change in the variable, and the change was never reflected back because it was running with a different assumption. And so when we emulate, we have to generate something called barriers. So we need to ensure that when a variable is changed, read, or written to, we need to insert barriers so that all of the threads in the app can actually see. Now, if you take a naive implementation of this, right, like typically we would just insert a barrier every time you load and store, basically every time you read and write to a variable. But if you do that, barriers are fairly expensive.
Yeah, it's like monitors or semaphores.
Exactly, they're super expensive. If you just do that, your performance will just go to tank, right? Like things will lag. So we have to be super smart. We have to be very clever about how we insert barriers. We have to be really, really judicious. We need to make sure we don't insert too many because otherwise it's slow. We need to make sure we don't insert too few, otherwise it'll crash. So we have to be very smart. So we invented some interesting algorithms on how we do this, and that's it's a lot of secret sauce here in emulation, and that's why it's fast, right? And so that's an I don't know if that answers your
Yeah, it does. I mean, the thing about it that to me that's interesting is that like as we're going along, like, oh, it's just Windows, and you're all just sort of brushing away a lot of ingenuity that's gone into it, to make it so that I don't have to think about this.
Like you said, ISA, for example, Intel like x86 has one ISA. ARM has a RISC, right? It's a CISC. x86 is a CISC system. Like CISC means it has a lot more instructions.
Complex instructions.
Exactly,
computer, right?
exactly. And RISC is reduced stress instructions. So like one instruction on x86 could actually correspond to 5 instructions on ARM.
Right.
on ARM.
And ARM is a RISC.
ARM is a RISC, exactly.
And even like the way you, like if I remember RISC, like even the way like you move stuff around is different, right?
Exactly.
Like it takes like more variables for every instruction.
It has more registers, exactly. So it's all, we've hand waved through all of this and it just works, but there's a lot of complex algorithmic coding in there that we've
That's cool.
Yes.
All right, so I'm going to get back to the question. Sorry, I started hogging you guys. Simon says, will there be new WPIPIs for always connected specific features, for example, when building background tasks that might need to use cellular communications?
So a lot of the APIs, when we've built UWP, were designed to handle this. Again, we've built phones, we've built cellular connected systems. I'm sure we will come up with new ones. As we look at new scenarios for this form factor and this device, we will continue to add new APIs that are obviously that developers come and ask us for, saying, hey, I want to go do this, or is there a way of optimizing it? But a lot of this is just baked into the architecture of UWP. So most of those APIs are already there and function because we've supported them for years. Like on
my laptop that's very beefy and powerful, there's a phone mode or airplane mode, and I'm like, why would I now I see how the thinking has gone, that these devices are all kind of ubiquitous and also different in their own way that you're going to use them.
Yeah, and I think as a developer, I think again I would go back and say you want to think about the customer scenario that you're looking at, and you want to build your application in a consistent way, and then have the application be aware and smart enough that if it's running on different devices, right, it's going to light up different aspects of the functionality that tailor it to the experience that is on that device. One thing I will point out there that is just that at this point in time, we are using the built-in LTE connection for data, right? These devices at this point in time are not using the telephony stack on that cellular connection, and so just so that there's no ambiguity around that.
That's cool. All right, we're going to just burn through these questions because according to my clock, we have about 14 minutes. Are there going to be apps that work only on these devices?
We're not designing so they're only APIs. If developers choose to build apps for that, they can.
Okay. So there will be because someone chose to make them only for that kind of device.
Right.
Okay. If I'm a C++ developer, is there any optimizations I need or can do for an x86 or UWP application? I feel like we answered this question a little bit. You know? Just make sure that it runs fast on an x86, and he's going to take care of the rest. That's what he said. So, Jim, are Edge and IE running as 64-bit ARM binaries? Are there also x86 versions in the OS? Which version does it run?
So, in the currently released version, Edge is ARM32. It's not ARM64. In the future, we will consider moving Edge to ARM64. IE, that is in-box, is an x86 version of Internet Explorer. So,
there you go. All right, next one. Kevin, the thing that is most interesting to me is instant capability. How fast can we expect the system to turn back on after pressing on the power/sleep button?
So the interesting thing is these devices, at least on the Qualcomm chipset, don't go to hibernate, right? They're in connected standby. And so my joke is I actually open up and it is instantly on. As soon as I open the device cover, I almost wish we could do a demo of it. It's funny because the hello icon actually shows up faster than like the Windows whole screen things, and I'm at the desktop. And so it was funny when I was at CES last week. I actually lost the ability to sync my phone with email. And so if you were at the show, you would have seen me walking around and going down the escalator and using my Always Connected PC as more of my mobile device. I'd open it up, I'd sit there hands-free, my calendar was there, and I'd close back and be in my bag by the time I got to the end at the bottom of the escalator. So these things are fast. I don't know if you can.
Do you want to demo it? We can demo it if you just want to see quickly.
Yeah, sure. I mean, I don't know how we can get a camera in here.
Well, you can see the top screen, I guess. And then, so I'm going to turn off the power button, so that's off. It might not connect back on.
Yeah, that's okay. Try it. Let's try it.
Let's try it.
So I will tell you how soon it's coming up. So pushing the power button, there it is. It's back.
That's right. Yeah.
It's trying to find you.
It's trying to find
You're
you.
not centered.
There you go.
Yeah.
And so, I mean, it was on super fast. I'm not crossing my fingers now. It's just a connection to our TV.
Yeah, the connection
And that
is-
is about one of our ability to kind of leverage the underlying ARM architecture and partnership there to take the experience I'm pointing to your mobile phone, but that experience you have on your mobile phone that customers expect, and now bring it right to that PC in that scenario.
All right, Jim, how do we debug an app under emulation? Will we see x86 or ARM instructions?
It depends on what kind of debugger you would use. So the typical way I would try to debug an x86 app is using an x86 debugger. So you can install x86 WinDBG or do an x86 remote debugging, and you will see x86 instructions. If you use an Arm64 debugger and then connect to the x86 process, then you will see the Arm64 instructions. You have to change you have to do fancy debugger commands to change tags and all that, to change context so that you can get everything. But it depends on what debugger you use. Typically, if you're a standard developer, please use x86 debugging so that it just looks like x86 to you. You don't have to worry about emulation. Like I said, design for x86. Don't worry about the emulation. Expect the emulation to just work. So just debug as an x86 app.
I'm pretty sure I'm not going to go into is this using the right move EAX to EAH?
Exactly.
I don't
Exactly.
know. I feel like it shouldn't be EAH.
Exactly.
Right? I don't know if I'll ever do that, but if someone wants to,
They can.
okay. All right, we got to hurry up. They're telling me to hurry up. What is the binary footprint on a device compared to x64 Windows, since you need to have additional binaries there?
Yeah, I mean, it's the same as an x64. On x64, you have x86 syswall64, you have program files x86. The same directories are on this.
So it's just the same.
It's the same as an x64.
All right, from Lance. So I can see people ignoring this for multi-threaded x86, compiling for ARM and shipping. Results would be lots of crashes. I think Microsoft needs to talk more about this as developers advise for multi-threaded apps. And I think we got into this when we talked about memory for multi-threaded. It's not a problem because of the way that you've done the memory barriers.
That's right, exactly. We handle multi-threaded apps. We understand how the architectures map. We understand how the memory model is. Like I said, don't worry. Write like an x86 app you would normally, and we will handle it.
Yeah, and like I said, for any computer science problem, once you introduce threads, now you have two problems, right? I think that's how it goes. Anything I need to look out for if I create code JIT on the fly in these environments? Will there be additional overhead?
Yes, that's a good observation. Yes, so if you do generate code on the fly, then it takes a little bit more header, because typically what happens is we execute the x86 instructions and we generate ARM. But if you're running x86 instructions and you're generating a JIT, like you're generating code on just in time, then we'll have to do a double hop, right? Because you first run x86 code, we run that to ARM, that ARM code now generates your code, which is as x86, then we have to take that x86 code and run and again generate an ARM. So you have a double, I don't know if I'm making sense.
Yeah, it makes sense. Because when you're JITting, you're not JITting in x86, you're
Exactly.
JITting in ARM to generate x86 code, which then needs to be put into the ARM again.
Exactly. So you have a double hop there. So he's right that he noticed that would be slow, and that is just physics. I mean, there's nothing we can do.
Last question, how do I test debug on a Win 10s device? I think you showed us.
Yeah.
You just literally from the machine, you go in there and put the IP
I
address?
unlocked it to Pro, enabled developer mode, and that's it.
So you're really doing a remote debug.
Yeah.
That's really the answer, is you would remote debug to the Win 10s device. You would not be natively running on top of that. I think that's true for ARM and x86. Is, the Win 10s device is not really the device you debug on, it's debugging your device to, in essence. You run VS on your Pro, and you debug it to the 10s.
Awesome. So to wrap up, just a couple of last parting words. Any advice you have for people that are moving forward on why this is kind of cool for devs?
I think Erin said it pretty well. It's cool for devs because on day zero, all your apps just work. If you have written an x86 app and you've never seen ARM in your life, don't worry about it. It will just work on this.
That's a pretty good pitch. I mean, I'm not gonna lie. Erin?
Yeah, I think for me it really is challenging people to think about the scenarios that this unlocks, right? And what is the user mindset going to be like thinking about taking the expectations they have of their mobile device, bringing in this type of device, and what applications and scenarios can you really, empower your users to be able to perform by thinking about this new category of always connected PCs?
Well, I'm excited about them. Kevin, last words for this edition of Community Stand-Up.
So I think you'll see as we create these new categories, our goals are to give developers and our customers more places and more ways and more opportunities to sell, make money, partner, whatever they want to do with their product. There's just more opportunity with these new categories. And as we saw two-in-ones, it really does inspire people to do things differently. Or even Surface Studio, one of these incredible devices. I think this is going to have the same impact. As developers, yes, today what you've got works. So you can trust us, all those things will value. Now what can you do different? How can you change things? How can you change the game and reinvent your business with these new categories and in essence engage your customers in new and creative ways?
Awesome. Well, I'll let you have the final word there. Thanks so much for spending some time with us with the Windows Community Stand-Up with Kevin Gallo. As always, your questions are always welcome. They always want to hear your feedback. Thanks so much for being with us. Thanks so much for watching, and we'll see you next time. Take care.
Thank you.